So this is our final assignment project for data visualization topic for open data with storytelling. So our topic is about Toronto motor vehicle collisions with key safety indicators. So this is the story one, and I have the dashboard and the sheets as well here. So coming to the introduction part, so we are we have to do 10 narrative questions, out of which we divided the task into three questions for each person. So for me, the first question is, what age groups and roles are most affected by the collisions? So this is the storytelling for that. And as you can see, this is the chart. This is the first chart of the bar. This is the bar groups, and this is the age of the person which are included in the collisions. So in the first story, we start the understanding who is the most affected by the collisions, and the age groups reveals that the highest, which is the highest age group with the maximum number of collisions. So it is clear that the vulnerable users, such as the pedestrians age 65 and above and cyclists in their 20s, experience higher severity levels are found. So you can see the area wise chart over here. Yeah, so this is the line chart for the age groups for the count of motor vehicles and collisions versus the age group. So young drivers, so I have attached a website for the Canada's website for the Toronto collision details. So young drivers are the most often involved in collisions, while pedestrians and cyclists, particularly older individuals, face a greater risk. So coming to the story point 2. So this chart over here shows the different driver actions lead to vary levels of collision severity, and for minor incidents to fatal outcomes. So this is a tree chart. In this we explore why collisions happen and how different causes related to the severity. So higher portion of severe or fatal outcomes, the collision causes by type of visual further categories, and that may be incidents revealing patterns between codes categories and the type of the road users involved. So basically this is a chart for the road users, what kind of fatal is the injury, is fatal, non-fatal, or property damage. So here comes the pie chart, which tells us what are the causes of the collision basically. So this is the map distribution. In this I have used the spatial file as well. So these are the areas for the same. These are the three visualization, and this is the conclusion. So we reach at a conclusion that frequent causes like distraction drive and most collisions, but most severe outcomes often results from less common yet highly dangerous actions. And here I have mapped the severity of the police divisions with hotspot areas, helping targets and safety. So this is my second it is the story type of this story is a geospatial comparison. And coming to the third story, so this is my third storyline. So my third narrative question will be, how do pedestrian and cyclist collision differ from other type of location, time, and causes? So basically the collision numbers have fluctuated sharply. So this is the 15. I've taken a chart. So this is the comparison chart for 15 years of the age groups versus the time period and the number of accidents happen. So here most of them are because of the speeding. Most of the collisions are because of the speeding, and improper turns dominate across road users. So as you can see over here, improper passing, this is the improper lane change, and this is a bar chart. This is my second visualization, and this is the third one. And I read here the conclusion. I have attached a big Toronto Police Power BI dashboard. It's a web form and a web page where you can see the last 5 years facts. So this is my dashboard, you can see over here. So this is my dashboard. So here we reach at a conclusion for my three priority points. Over the past 15 years, the collision patterns have fluctuated sharply, and most of them are bicyclers. And uh, this collision in road rages happens because of the vehicles, and vulnerability does not allow align with collision further. Thank you.
Hello, Professor. This is Kusuma, and this is my Tableau project um, on Toronto traffic collision. In this presentation, I will show four story points that explain how collisions change over time, how environmental conditions affect collisions, how human factors contribute to accidents, and which neighborhoods have the highest risk. So, I have done four story points, and my other groupmate has done the remaining. I created 12 worksheets, four dashboards, and one story for each dashboard. So the story point one is the trend over time, that is the collision trends over time. This first slide shows the overall trends of collisions over time, which helps us get a big picture understanding before we go deeper. The first chart is the monthly trend line where I plotted the number of collisions per month. Here we can see whether collisions are generally increasing, decreasing, or staying consistent across months. Next, I compare collisions year by year. This bar chart shows uh, like how the total collisions in each year allowing us to see which years experience spikes or drops. This provides a quick summary view of the data at annual level. The final visualization in this dashboard is the heat map of month versus year. The darker colors represent highest collision counts. This heat map helps identify seasonal patterns. For example, if collisions increase in winter months or drop during summer. So the overall, this story point provides a zoom out view of data. We can see long term patterns and seasonal behavior, which prepares us to drill down into what be causing collision peaks. And this is my second story point, which is the environmental factors. That is the environmental factors that causes the KSI collisions. The second story point focuses on how weather and road conditions affect collisions. The first chart here breaks down the collisions by road surface conditions. We can see categories like dry, wet, snow, and slush. This helps us identify whether poor road conditions significantly increases collision numbers. The second chart analyzes collisions based on visibility, such as clear, fog, rain, or snow visibility. To add more meaning, I included injury level so that we can see not only how collisions happen but also how severe they were under each condition. The third visualization on this dashboard is a tree map combining road conditions and visibility. The size of each block represent the number of collisions. The color of each block represents the number of collisions, while the color indicates the visibility. Um, and sorry, the size indicates the number of collisions, while the color indicates the visibility. This provides a quick way to see how which combinations of conditions are most dangerous. This story point helps us understand that that environment plays a major role in traffic safety. For example, collisions may be more frequent during the wet or snowy conditions, or reduced visibility may lead to more injuries. This drill down view explains why we see certain patterns in story point one. So this is my third story point, that is the human factors that affects the collisions. And we basically focus on human behavior and the vehicle actions. The first chart analyzes collision vehicle type, such as the passenger cars, trucks, bicycle, and motorcycle. This helps identify which vehicle types are most involved in collisions. Next, I created a heat map based on driver action versus injury. So the driver actions include things like speeding, improper turning, inattractiveness, or failing to yield. By adding injury severity as rows and collision counts as color intensity, we can quickly see which risky behavior led to more severe outcome. The third chart breaks down the collision by vehicle maneuver, such as going straight, turning left, turning right, passing, or stopping. This shows how the drivers was doing during the moment the collision occurred. Together, these three charts helps us understand that the human side of collisions, human error, distracted driving, and risky behavior appear as a major contribution to the accidents. This zoom-in approach helps us identify preventable causes. And the last story point that I've done for this project is the geographical analysis to see where the collisions happen most frequently. The first visualization is a geospatial map created using the geometry map. Here, each region is has different color based on the number of collisions recorded. The yeah, where you can see the number of collisions occurred depending upon the colors. Next, I created a neighborhood a ranking bar chart. This chart lists neighborhoods from highest to lowest collisions. Um, Collisions clearly showing which area require the most attention from the city planners. The last chart is the bubble map, which where the larger circles represent the higher collisions and the color indicates injury severity. This visualization highlights both frequency and impact, making it useful for comparing neighborhoods visually. This geographic analysis helps identify areas where targeted interventions such as the speed controls, traffic signals, or better road design may significantly reduce collisions. So, to summarize the findings from all these 4 points, collisions show seasonal patterns with certain months and years, and also the road conditions, reduce visibility, and these collisions also depend upon the human behavior, as mentioned, speeding, inattention, or improper turnings. And also we can see that certain neighborhoods will be having more collision rates compared to the other, where the traffic safety improvements are needed. By combining these four perspectives, we gain a complete understanding of when collisions happen, why they occur, who is involved, and where they happen most often. Thank you, Professor. And this is my work, and I've done 4 story points. Thank you.